Alright, this video is covering number 13 from 3.4 day 2, and hopefully I had a chance to try it. The tricky part is you gotta write the constraints, which is just a system of inequalities. So I guess the first thing we should say is our two variables are like how many spruce trees we're gonna make and how many maple trees. So I'm just gonna use an S and M for my variables here. Alright, and then we know that like our money, the max we have is $2,100. So basically we have to stay below that. So our whatever we spend has to be less than or equal to 2,100. Okay, and so this is where this data comes into play because it's $30 for a spruce tree plus 40 for a maple. It has to be below 2,100. Okay, and then we also have a max amount of space, which is 4,500 square feet to plant these trees. So again, we've got to stay less than or equal to that. Sorry for that. It should be a 0 there. 4,500. Okay, and then here's the area, right? So the area is 600 for a spruce, and then 900 for a maple. All right, and then kind of the weird part of this is the objective function, is we want to take out as much CO2 as possible, right? So the CO2 we take out is right here. It's 650 for every spruce tree and then 300 for every maple. Okay, so that's our objective function, and we're trying to, let's see, maximize that because that's how much CO2 we're taking out of the atmosphere. Okay, so we want to maximize that function. All right, and then the only other two inequalities, which again I don't always include them in my questions, but basically we should have positive, like basically can have negative number of spruce trees and negative number of maple trees. So technically both of those should be greater than or equal to 0. Right? But all that really means is that we're focusing on our first quadrant. Right? So in our graph, we're not going to go into the negatives for x or y. We're going to focus just on this first quadrant up here where both x and y are positive. Right? That's all that this really says. So yeah, so that's it. That's the setup. Here's our equation, and there's our inequalities. All right, and then if you want to, try the question at this point, that'd be great. If you still want to see the rest of it, I can do it on Desmos here real quick for you. So basically, I'm going to type these in and just use x and y instead of s and m. Oh, and I realized I messed that one up right there. It should be an m for maple tree right here, not s. Sorry about that. It should be an m. Okay, so I'm going to treat s as x and m as y, and then graph them in Desmos. Alright, so I typed them in, right, and obviously I'm not doing the greater than or equal to 0 ones. I feel like that makes the graph more complicated than needed. Alright, and the other thing is obviously I can't see anything here. So these are huge numbers, so I just need to zoom back. I'm going to zoom out so I can start to see a picture of it. Right, now I got a little bit better picture of what's going on. I need to be below both lines because the mouth is facing away from y. So I basically need to be in this region here. Okay, so I get this point, and then here, if I look, this is kind of one of the hard parts is I want to be below both lines. So when I'm out here, I want to take this inside point. Okay, so when I do my vertices, I'm going to do this one right here, the one inside here, and then again the one on the inside up here. Right, so those would be my vertices, and 0, 0. Though, I mean, I don't think 0, 0 is a realistic answer here because, then you're not going to take out any CO2 if you have 0, 0. Right, so basically then I would just need to test those vertices in the function. Come back here and try those. So I'm going to do 0 spruce and 50 maples. So if I plug that in here, it'd just be 300 times 50 plus 0. So that should be 15 with 3 zeros on the end. So 15,000 CO2 stuff out of the air, pounds per year. 30, so I just need to take 650 times 30 plus 300 times 30. I got a little bit better. That got 28,500. And then last one is if I did all spruce trees and no maple trees, so it'd just be 650 times 70. All right, and we can see that that comes out as the best option. That's the most CO2 getting absorbed out of the air. Right, and then honestly, at the start, this is kind of a stupid question in a way, because if you look, the spruce tree is better in every way. It costs less, it takes up less space, and it takes up more CO2. Okay, so it kind of makes sense that we would do all spruce trees and no maple trees because it's kind of better in every way. So it's a little bit of a strange question, but anyways, our answer is 70 spruce trees, no maple trees, and we get rid of 45,500 pounds of CO2 a year. All right, now that is it. Thank you for watching.